we were below 65, it'd be white. The vac switch, this says the vacuum, the process chamber is under vacuum. You need both of these to be able to reset the safety circuit. The safety circuit's a manual operation, so if both of these are good, then you can go ahead and reset the safety. That's a requirement. You have to have that to run the process. So when we bend, we lose the vac switch because we're at atmosphere. We pump back down, we're going to have to reset the safety circuit to be able to run the process. That's not part of the recipe. And then you have the exhaust, the roughing valve, and 4-line and schematic, the PC 4-line vent, and a purge ISO. That was on the back side of the 4-line. That's where your N2 comes in. That's really the only N2 that you have coming in here. This helps keep it clean. Your N2 will last a long time with this. You won't use very much at all. The PC roughing valve open and close signal, there's 2 switches on the top of the roughing valve, 2 micro switches. That's where these signals are coming from. The PC roughing valve, that's something that does require maintenance. Usually we recommend doing maintenance on it every year, 2 years. It has an O-ring on the bottom seal. That O-ring will eventually get coated with whatever your process is running, so you'll get a little bit of leak by over time. But it's not necessary for it to not leak for the process because it's normally open. It's just something, after so much period of time, you're going to have to change that O-ring. The deposition tab, you have a graph that gets populated. Whenever you launch the software for the first time, this should automatically nest in here. Sometimes it doesn't nest. If it doesn't nest, then you can close the software and relaunch the software. That would only happen during startup. So you have the graph that monitors PC Catman pressure, ALD cycle counter, and your cycle set point. This is a schematic of source 3. It's shown a 3A, which has the TMA. 3B, this is actually empty. So we'll put empty here. And then you'll have what's called the carrier gas. This is just the argon that keeps it clean.
I'm sorry, what is 50?
That's the FCTMs. So this is saying, I want
input? Is the input?
Yes. This is input, this is output. So this is the input into one of the MFCs here. Okay? And then this acts as a metering valve that tells it, okay, I'm putting 50 SCTMs out. Well, right now you have regular argon or regular nitrogen hooked up to the system. The next time you order an argon bottle, you should order a purity of 4.9s. It's called 4.9. I would have a higher purity level than what you have on there now. For just getting used to the tool and getting used to the process is fine. But if you're really wanting to get results on a process you're trying to really tune down on, you should have a higher purity argon than what you have.
What do you mean by higher purity? Like in terms of number?
The term's 4.9s.
4.9.
Yeah. If you ask for 4.9, it doesn't have to be like an UHP, but it has to be better than what's there. Should be. I'll just use should be. So yeah, this is the gas that's coming through, the carrier gas that's coming through source 3. This is the carrier gas that's coming through source 1. Same information as you had on the other screen here, plus you have additional buttons. Some of these buttons are redundant on what screens you can see them on. And these are also redundant. The same thing as you've seen over there. Stop ALD layer. This is just a nice way. If you wanted to stop it before, you could hit stop ALD layer and it'll finish on that cycle. It'll allow the cycle to complete and then it'll stop. Or like yesterday we were doing, changing this, say smaller number. So if you have 400 cycles, you could change it to maybe you're on cycle 200 of 400 and say, oh, I want to stop this. You could plug in 201 or 202. I didn't even know that was there.
I'll play around here with that.
Yeah, nice to know.
Sorry, sir. Wait. You wanna just know?
Okay.
You wanna just recording? Meeting.
Share it?
Share the screen. Share. Share. The screen.
Yeah, that would be easy.
This meeting is being recorded.
So that's a general overview of the deposition screen. The process screen, you have the same graph, just looks a little bit different. And you have the matrix. For probably the next year or so, you'll only be doing an A/B process. You may get into, like if you were doing hafnium, you could do PMA H2O, hafnium H2O. So you could have a 4x2 or even a 4x4 recipe for later on. This is our standard matrix that you could expand into over time, depending on what options you have. For the most part, you're just going to be using this area right here. Just like we did with the water and the PMA. You have the process phase. You can look at these as lines. Process phase, ALD gas flow mode, and ALD heater mode. These are set as lines in a recipe and populated in this information box. Finished ALD layer as redundant as the other screen. You can clear it, react, and definition. So if somebody stopped the recipe in a not nice way, they just stopped it from the recipe monitor instead of allowing it complete, you may have a situation where the reactants have been left populated in a matrix. So if you run a recipe on top of that, it's going to stop at that point, and you might have to hit clear AO or clear reactive definition to clear that screen. ALD process active, this is just a discrete input that's given through the recipe, and all this is redundant for the process chamber as before. Heating. This is the general user heating screen. So you have enable heaters, off all heaters, and reset all over time. If you wanted to do this manually, you could do it here. The recipe tells it to do it, so you don't have to do it manually.
So no need to change on the heating screen.
It's good to check, but you don't have to do this. These are the commands that are already called up in a recipe. The substrate heater functions, that's this section right here. The control for the substrate heater is different than the control for your line from the process chamber. So, and this is still all controlled through the recipe. But if you go, you can turn it on and off manually if you wanted to. You could give it a set point and control it manually. Most of the time it's controlled through temperature control, so you have a ramp and heater set point. That's actually the preferred way to run this. Tuning, you won't be doing any tuning. This is where if you wanted to play around with the PID values, you can do it here. And if you wanted to put a different over temp set point, you could change that here. On this heater screen, you have enable. Enabled means the command was received, and you have a temp set point. You're only showing one TC, one of the two TCs on the screen. This would be the control temp. Your output set point is just what the percent output is giving to the heater relays, how hard they're driving. Heater definitions, we've already covered those. Error, if one of the heaters go out or it over temps, you'll get an error and it'll automatically shut off. This 6553 is the default 65535, so if you have a thermocouple that's unplugged or one that goes bad, sometimes they do go bad, it'll read 65535. If there's a difference between a control and an overtemp thermocouple or TC1 and TC2, you'll get an error. If you overtemp, you'll get an error. There's different things that can cause errors. To clear it, you just reset all overtemps. In a maintenance screen, under system info, you have recipe logs, events and other logs. This is where you could actually come in and your archive is under here. So if somebody did something and they went up and they cleared acknowledge, and said, I didn't do nothing. No. This gets recorded all the time. You can come into the events and open it up and figure out what happened through here. That gets recorded and backed up every 24 hours. What is that? Yeah. Under maintenance, system info. Some things were put into the software, but they're not incorporated 100% yet. One of them is system drawings, so you won't have any system drawings. It's set up for things that will happen in the future with the software. If you want to disable the interlocks, you can disable interlocks from here. Not recommended, but sometimes you need to do that for troubleshooting. So just be aware to disable interlock for here. If you want to back up the controller, maybe you have a lot of critical recipes after, say, 3 months or 6 months or a year, you could back up, do a backup and it'll save all the recipes and other inputs. But you can back it up. Series support file, I have no idea what that is. I'd have to look in the manual. Some values, you can scroll down here on a scroll bar. I never use this. If I'm coming into this screen under this tab, I'm usually disabling interlocks, or I'm digging into events and other logs. System signal tab, you can come in your analog string outputs, inputs, discrete outputs, and discrete inputs are here. This is more information under the maintenance than you see under like operation. Maintenance is a lot more information. You can come in, you can scroll down, depending on if it's an output or an input. You can set the output, you can monitor the input, come in. Discrete outputs, if you push any of these, It's the same as pushing a button on other screens. However, there's operations that you could do from here that are not buttons on other screens. Again, just a lot more operations from here. This is something that not everybody should be getting into. You can scroll down and you can see the different names. And as I said before, if you bring the cursor over something, you can see exactly what the signal is named as. It's not always intuitive. Sometimes they're just a little bit different. Mostly if you're looking for that signal name in regards to charts or signal recording, you might want to hover. I want to record this. I don't know what it is. So it'll give you what the signal name is actually, and then you can go in the pull down menu and put it on a chart or put it into the recording. The discrete input is just exactly what it is. It's an input. So it's a 1 or a 0. This section here, you won't touch it. Software manipulates this part of it. Interlocks, these are all the interlocks. The software interlocks that are tied to this system. I'm not going to go through every single one of them. If you want to, you can kind of click on them. You can come in here and you can say, here.
We don't usually need to change.
You should not. There's reasons for it. We might disable some, like if we're troubleshooting, but there's a purpose why they're here. Now, like we've had a couple interlocks before come up with the yellow. It's much easier to double click on that and it'll bring you to the exact interlock. There's both behavior